On your copy, but not on everybody's copy, it says something about gluten-free dishes. I changed the assignment. I took out the gluten-free, so you can cross that out there if you see the gluten-free right there. So we have our menu with 3 appetizers and 5 entrees. And for the appetizers, 2 of them have to be vegetarian. 1 of the vegetarians is the chef special. For the entrees, 2 of them are vegetarian, and 1 of the vegetarians is the chef special. There are going to be 100 visitors to my restaurant on a day, and 10% of my customers will be vegetarian. So I put 10 out of 100 customers are vegetarian, 90 out of 100 customers are no restriction. And then I split the vegetarian customers between the 2 appetizers that they could have. Morning. And I split the no restrictions between all 3 because they could have any appetizer they want. So I had 30, 30, 30, and then we added up across. So now we're going to use this table to do some probabilities. We have to find the probability that a customer chose appetizer 2, and appetizer 2 is the bacon wrapped figs. Okay? So think about how many chose the appetizer 2 and divide it by all of the customers. And you can give me that as a simplified fraction or as a decimal. Okay, so you had 30 customers who had the bacon wrapped figs out of 100 altogether. Now you can simplify that to 3/10. Remember, if you put that into Desmos, it will simplify for you. Or you could have the decimal 0.3. All right. Find the probability that a customer chose appetizer 1 or appetizer 3. So remember, you have to include both appetizer 1 and appetizer 3. All right, so when you added those together, you got how many people? 70, good. So 70 out of 100, which is going to give you what simplified fraction? Did you say it? It is 7 out of 10. And some of you might have made it a decimal, 0.7. All right, find the probability that a customer was vegetarian given that they had this chef special appetizer. So remember, when you say given, it means that your denominator is no longer 100. How many people had the chef special appetizer? Let's see, it's this one, the salad. How many people had the salad? Yeah, so it's going to be out of 35. Okay, so out of those 35 people, how many of those were vegetarian? It might be. I can't do that math in my head. But how many people? 5, yeah. So we got 5 out of 35. Now you can simplify your fraction to 1/7. Did anybody else calculate that? Can anybody confirm what Shelby told us about 14%? Kelly, what'd you get? Right, 1/7, and then turn off the fraction so we can see the decimal. What'd you get for the decimal? Sorry, I can't hear. 14%? Yeah? Okay. All right. Make sure you have that because we're going to turn the page. Yeah, good. Any questions so far? I see some people are still looking. That's good. All right, so next what we're going to do is a tree diagram, and we have not done a lot with tree diagrams, so this is a little bit new. That's okay. We're going to get through it. All right. On the tree diagram, first we have all of our people split. Oh, I don't like that went through there. Let me see if I can do another one. We have all of our people split between no restriction and vegetarian diet. So do you guys remember what % of people were vegetarian in London, Ontario, Canada? 10%, very good. So we're gonna put the 10% as a decimal, 0.10. And then what decimal will I use for the no restriction people? 10% are vegetarian. What % has no restriction? 90, good. So I'm going to do 0.90. All right, we need to list the choices, and we're going to list them shorthand because these are long names for these entrees. For no restriction, they can have any of the entrees. So they could have salmon, they could have chicken, risotto, tofu, or spaghetti. So if there are 5 things they could have, what's the probability that they're going to pick any one of those 5? If there was one thing, it would be 100% probability, but there's 5 things, so we have to split it up. What do we get if we divide 100% by 5? 20. So we have a 20% chance that we'll pick any of these. If we have no restrictions, we're saying that people are equally likely to choose any of these. All right, but if they're vegetarian, they have fewer options. So which ones can they have if they're vegetarian? It does tell you on the menu. Which ones can they have? Turn to the front, look at your menu. Can they have the salmon?
No.
Nope. What can they have?
Salad.
They could have salad, but remember we're looking at the entrees, so on the right side. Which ones can they have on the right side of the menu? Yeah, so they can have risotto and they can have tofu. Now, vegetarians only have 2 options, so we only have to split the 100% in half. So what's the probability that they're going to choose the risotto? We have 2 options, so we're cutting the 100% in half. Probability that they choose risotto is what? 50%, very good. So we're going to do 0.50 and 0.50. All right, so when we're trying to find a probability, you multiply down the branches. So if I want to find the probability that somebody chooses entree number 1, which is the salmon, entree number 1, I'm just going to write salmon above it. I multiply the no restriction times the salmon. So I'm going to give you guys a minute to do that. All right, so if you just multiply it and keep it as a decimal, you should have gotten 0.18, which is fine. I'm happy with 0.18. Or if you change it to a fraction, you'll get like what Joseph got. You'll get 9 out of 50. All right, what is the probability that a customer chose a non-vegetarian entree? So that means that they chose the salmon or the chicken or the spaghetti, okay? So non-vegetarian is salmon or chicken or spaghetti. I know I wrote that real small, but I did say it for you. Salmon or chicken or spaghetti. So basically we have to find the probability of each one and add them up. So it's going to be no restriction times salmon plus no restriction times chicken plus no restriction times spaghetti. Okay? So 0.9 times 0.2 plus 0.9 times 0.2 plus 0.9 times 0.2. We have to add up all the possibilities. And definitely Desmos is going to be better at these complicated multiplications than just a regular phone calculator. But you can open Desmos on your phone. Just open it on your browser. You don't even need an app. All right, so it looks like I forgot to move the chef special. The chef special is supposed to be this one with a star. So on your menu, go back and fix the chef special, because the chef special has to be one of the vegetarian ones. All right, so for the tofu, it shows up here, 0.90 times 0.20, plus it also shows up down here, 0.10 times 0.50. All right, so we know that this one here is going to give us 0.18. We've done that a few times. And then this one here should give you 0.05. And when you add it up, what do we get? What'd you get, you, Lisa? Anybody else get 0.23? Kelly, you got that? Good. Yeah, good. All right, so we get 0.23. There's a 23% chance that a customer is going to have the tofu. All right, creating the Venn diagram this time is a little bit tricky. Because I don't give you exactly what number goes in each spot, but on the side here, I'm explaining it. Are there any questions about the top part before we do our Venn diagram? Okay. So we're going to find the middle number by multiplying the probability that somebody got the appetizer special times the probability that they got the entree special times the 100 customers. So remember that when you want to find the probability that two things happen, you have to multiply their probabilities together. So going back to the front, sorry, I got on this page. The probability that somebody got the special, all right, is 35 people out of how many altogether? 100. So the probability that they got the special appetizer is 0.35. All right, the probability they got the entree special, that one we just found it, 0.23. And then times 100, and that's going to tell us how many people go in the middle. Now, these are actual people, so I can't put down like 2.3 people. So I'm going to round it. But go ahead and find a number there. Did anybody else get 8.05? You did? Yeah? Okay. So we get 8.05, and we know that we can't have 0.05 people, so we're going to round it to 8. Okay, so we'll put those 8 people in the middle. Those are the people who had both. All right, for the left number, it's going to be the probability they got the appetizer special times 100 customers, and then we'll subtract out the middle number because we already counted those people. So the appetizer special, that was the 0.35. Remember, we said 35 out of 100 people got the appetizer special. So it's 0.35 times 100. And then we subtract out the middle number that we just got, 8. And that's going to tell us how many people are on the left for the appetizer special. All right, Joseph, what'd you get?
27.
Anybody else get 27? Good. All right, so 27 people had the appetizer special, but not the entree special. And 8 had the appetizer special, and they also had the entree special. So that means altogether, 35 people had the appetizer special, which we knew, because it's right here. All right, the right number is the probability of the entree special times 100 customers minus the middle number. And the entree special was right here, 0.23. And then after you find that number, I want you to figure out how many of the 100 customers had neither special. Okay, so we get 15 here. 15 customers got the entree special, but not the appetizer special. And then we know that there were 100 customers altogether. So if I subtract all of these out, 100 minus 27 minus 8 minus 15, what do we get? 50 customers are left, right? So those 50 customers, they chose other things. They didn't have the chef special. That's okay. You get to choose what you want. So we're going to use that Venn diagram now to answer these questions right here, 7 and 8. And then we're going to do some permutations and combinations. So I want you to try 7 and 8 right now. All right, so the probability that a customer had both specials, that means they had to have both. It's not an or, okay? So if they have to have both, how many are in the overlap between the two circles? 8, good. So there are 8 that had both out of all of the customers, which was how many altogether? 100, good. And then I saw some of you simplified that to 2 out of 25. Some of you made it a decimal, 0.08. I'm fine with either of those. All right, probability a customer had the entree special given that they had the appetizer special. Most of you had the right idea here, but some of you looked at the wrong side. So let's take a quick look. They had the appetizer special, which is on the left. So we're only considering these people. How many is that altogether? It's 35 people altogether. So the people who had the appetizer special, that was 35. And that's going to be my denominator. Then out of those 35, how many of those 35 also had the entree special?
8.
Yep, these in the middle. Okay. I did like seeing that almost everybody changed their denominator there. That's a key idea, knowing that it's not out of 100. It's good. Any questions on 7 and 8? Okay. We're going to do permutations and combinations, and then after that, those of you who haven't finished the last project, you're going to do that. Those of you who have finished the last project, you're going to start thinking about your menu, okay? Because your own project is going to have your own menu on it. You and your best friend decide to choose 2 entrees to split. So since you're splitting them, it doesn't matter. The order doesn't matter. How many ways could you choose? So if the order doesn't matter, is that permutation or combination? Think back to your warm-up. If the order doesn't matter, permutation or combination? I heard a vote for combination. Anybody else want to agree with combination? Yes. If the order doesn't matter, that is combination. Now, if you like doing combination with the fundamental counting principle or with a formula, you can pull out your notes from last class and do that. In the warm-up, most people were using the NCR. So you're going to type that, N, capital C, little r. And how many entrees are we choosing from on the menu? Go back to your page 1. How many entrees are on the menu?
Oh, like 7, 5.
5. Yep. There are 5 entrees on the menu. So we're choosing from 5. And it's just you and one friend, so you're just choosing how many entrees?
1.
You're going to choose 2.
2.
Yeah. So you don't want half the food, you just want to try 2 different things. You're going to split 2 different entrees. So it's going to be 5, 2. And I'm going to give you guys a minute to put that into Desmos. So you type little n, big C, little r, and then parentheses 5, 2. All right, you and your friend decide to try 2 different appetizers. Since you are not sharing, order does matter because, for example, if I ordered the salad and my friend ordered the figs, that's different from my friend ordering the salad and me ordering the figs, okay? So the order matters this time, and if the order matters, what is that called? Permutation, good. So we're going to do NPR. And this time, it's the appetizers. How many choices do we have for the appetizers? 3 choices. Good. So this time it's going to be 3, 2. All right, go ahead and do that. All right, so there were 6 ways for us to choose our appetizers there. Very good. So this activity is one that I'm actually going to take from you, and not yet, but I'm going to take this from you and return it to you next class because this is going to help you with planning your own restaurant project, okay?